Okay, today we're going to talk about these things called compound inequalities. So compound inequalities, you solve them kind of the same as what we did last week. You graph them kind of the same. I say kind of because what you're going to see today are two or more. We're only going to see two inequalities joined together. And you're going to see the words joined together with and or the word or. And sometimes they don't give you a word at all, and they just join them together with their inequality symbols, less than and greater than symbols. We're going to walk through enough examples, I think, today to kind of really set you up for success the next couple of days. So today's might be a little bit note heavy, but it's to kind of help you out. So I want to show you what these graphs are going to look like with these compound inequalities because they're kind of weird. You're going to have two inequalities per problem, and you're going to end up graphing them on the same number line. And that's where it gets a little weird. So if you have an and compound inequality, so it'll either have the word and or it'll just have inequalities, which you'll see what I mean in a second once we go through and solve these. If you have x is greater than or equal to -2, what you would do is you would put a dot at -2 and you would shade to the right. That's what they did here. And then if you have x is less than or equal to 3, you would put a solid dot at 3 and shade to the left. But what if you have the compound inequality, x is greater than or equal to -2 and x is less than 3? How you graph this? You go to -2 and you put a dot. You go to 3 and you put a dot. If x is greater than or equal to -2, that means it would shade to the right. If x is less than or equal to 3, you would shade to the left. So you only shade where they are overlapping. So where do these overlap? If it's greater than -2, less than 3, where does the shading overlap? In between the two dots. So this is what an and graph ends up looking like. Because you would shade to the right for the -2, and you would shade to the left for the +3. So you only shade what overlaps. When we walk through these, I think it'll make more sense kind of too. So what this means is that any x value in between -2 and 3 would be a solution. So like 1 would be a solution, like that problem on the quiz. The number 1 would be a solution because it's included in here. Now for the ors, for the graph, you have x is less than or equal to -2, so you have a solid dot at -2 going to the left. X is greater than 1, so you have an open circle because it's just greater than going to the right. And then this is what the or would end up looking like. X is less than or equal to -2 or x is greater than 1. So you go to -2, you put a dot. You go to 1, you put a open circle. Will these overlap? Looking up above, do we have any overlap going on between the two inequalities? No. So you just draw the arrows that they have and you're done. They do not have any overlap. So you actually draw, ors will always go in opposite directions. You'll probably get sick of me saying that today. Ors go in opposite directions. Ands are connected. Ors opposite, same, they start with the same letter. And then ands are connected together. It's whatever's in between. And is whatever's in between. Ors go in the opposite direction. Now, what you have to be careful on, though, pay attention to whether they're open or closed circles. Are you shading in the right direction? That kind of a thing. All right, I want to show you what these compound inequalities actually look like that you will be solving. And I want you to flip it. And we're going to take a look at number 5 first. And we're going to walk through a couple of these before I let you loose on a few. So we have 2 is less than or equal to 3x plus 5, which is less than or equal to 14. This is a compound inequality. You're going to end up solving, and then it'll give you an answer. There's no or and involved in here, but because your x is in between, do you see how your x right here is in between the inequality signs? This would be considered an and compound inequality. When you solve them and they look like this, it's actually best case scenario for you because you only have to solve it once. These ones right here, you'd have to, we're going to do this here in a second, but you'd have to solve this inequality, and then graph. This one you can solve in one little like swoop. So if this were a normal problem and you had to solve for x and you had to get x by itself in the middle of this inequality, what would you do to solve for x first? If you had to get x by itself. Thinking back to your solving skills. What'd you say? Nope, I'm looking in the middle. Subtract 5. So I'm going to subtract 5 from the middle. And now because I'm solving a compound inequality, whatever I do to the middle, I have to do on the left and the right. So I'm going to subtract 5 here, subtract 5 here on both sides of the inequalities. So then I have 2 minus 5 is negative 3, less than or equal to. In the middle, it cancels. I have 3x, less than or equal to 14 minus 5 is 9. So I have negative 3, less than or equal to 3x, less than or equal to 9. So again, thinking about your solving skills, how would you get x by itself? Right here, x. I just want to get x by itself. So what would I do, Alan? I would divide by 3. Divide by 3 in the middle means I need to divide by 3 on the left and divide by 3 on the right. These ones right here, honestly, I think are the easiest ones to do. Bless you. But they're the hardest ones on quizzes and tests for some reason. Everything goes out the window when quizzes and tests roll around. So those cancel in the middle. You are dividing by a positive number, so you do not have to flip your inequality. Negative 3 divided by 3 is negative 1. Less than or equal to. Got your x by itself, which was our goal from the get-go. Less than or equal to 9 divided by 3 is 3. So this is your answer. That's your solution. So x is any number in between negative 1 and 3. That's what this means right here. X actually could be negative 1 and 3. So to graph it, here's our number line. They give you a number line down here. Just realized that. We have to put at the negative 1, let's see, we're going to put a negative 1 right here. And I'm going to put a 3 on the other side because negative 1 and 3. So negative 1 and 3. Does negative 1 get a solid or an open circle? Solid because of the equal to. Does 3 get a solid or an open circle? Solid because, again, the equal sign. And because x is in between the 3 and the negative 1, you only shade or put whatever, you connect the dots in between. So that's one where they don't actually give you the words and, or. Let's take a look at one where they actually give you the words. That might be a little bit easier. But you're going to see that it's going to be more work. Let's take a look at number 6. So for number 6, they give you 2t minus 3 is less than 4, or t plus 3 is greater than 10. So you're going to have to solve both of these inequalities separately, and then you're going to graph them both on the same number line. So for number 6, the first one, if I have 2t, I'm only going to focus on the first one. 2t minus 3 is less than 4. To solve that, the very first thing I would do is add 3, because I'm solving for t. I'd have 2t is less than 7. Oh, I get a decimal. And then to get t by itself, divide by 2. It's not a negative, so leave your inequality sign alone. So you get t is less than 3.5. Or, now we come over here. Now we have to solve this one. What's the only thing we have to do to solve that one? Subtract 3. T greater than 10 minus 3 is 7. So here are your two answers. Once you have your two answers, now you need to graph them by putting them on the number line. The smallest of the two numbers always goes on the left. Like on a number line, it goes smallest to largest. So between these two, 3.5 is the smallest, so I'm going to put that on the left. Ooh, it's not negative, it's positive 3.5. 7 is the largest, so I'm going to put that on the right. Do I have an open or a closed circle at 3.5? Open, because there's no equal to. What about the 7? Open or closed? Open. It says t is less than 3.5. So less than for the 3.5, does that go to the left or to the right? To the left. And then for greater than 7, t greater than 7, for the 7, does that go to the left or to the right? To the right. It's an or. Ors will always go in opposite directions. So that's really what you're doing today. You're going to be solving two inequalities and then graphing them. So if you could solve the inequalities, like it's kind of like, it's not too bad, but it's the same thing that we've been doing, except for you're doing two per problem. Let's see. Let's take a look. Let's take a look at number 7. We'll do number 7 together, and then I'll let you loose. I want to talk about number 7 because you'll see here, and maybe some of you already see why I would want to talk about this one. Okay, for number 7, so this one's joined together, so this one's going to be an and. You're going to end up, when you graph it, you're going to end up like connecting your dots together because it's one big happy problem there. What would we do first to get m by itself? Subtract 5. Good. Subtract 5 from the middle. Subtract 5 from the left. Subtract 5 from the right. Negative 1 minus 5 is negative 6. Bring down your inequality. 5 minus 5 is 0. You have negative 2m less than, bring down the inequality sign, 11 minus 5 is 6. Ooh, now what do we do? What do we do to solve for m?
Divide by negative 2.
Oh, divide by negative 2. What happens?
The inequality flips.
All of the inequalities flip. Because we're dividing by a negative, these signs have to flip the other way. Because you're dividing by a negative. Anytime you divide by a negative number, you've got to flip it. Negative 6 divided by negative 2 is 3. Bring down the m. 6 divided by negative 2 is negative 3. Okay, so now to graph it. On my number line, what number goes on the left? Negative 3. And on the right is a positive 3. Always put the smallest number on the left. Goes from smallest to largest. Open or close circles on these guys? Open. And then because your m is in between, you shade in between. All right.